Hello all. Good evening. I'm Shriram here and it's very nice to meet you through this medium. We are going to talk about the Internet of Things prospects and challenges for the next few minutes. And before I start, I would like you to go through the website youtube.com where my channel is there, Shriram Vasudevan. You can get to know a lot about IoT there and it will be very helpful for you to understand how to start building projects also. Other than that, we have recently released a book through Wiley for Internet of Things and it covers everything very comprehensively right from the scratch till the project building phase. To my understanding, the way the projects have been built and explained in our book is definitely different and good. So I request you guys to go through it as well and let us know the constructive criticism and feedback to improve the book in the next edition. We are right away getting into the session. Stay tuned. The agenda for the session is simple. I'm going to define what IoT is all about, the history, the application areas, stats a bit, characteristics, architecture, and a quick recap. This should not take more than 30 minutes, hopefully. I hope you will enjoy it. Let's understand what IoT is all about, followed by its history, characteristics, and application sectors in the first part of the discussion. IoT refers to the interconnection via the Internet of Computing devices embedded in the everyday's object, enabling them to send and receive data. IoT is all about collection of data and processing the data in a timely manner. But all these will happen with the help of internet is the point. This definition, whatever I have conveyed now, could be slightly complex, but IEEE has made it very nice, saying that a network of items, each embedded with sensors which are connected to internet, can be regarded as IoT. Very simple yet very effective. A network of items, each embedded with sensors which are connected to the internet. I need internet, I need items which are nothing but the equipment or devices which must have sensors with it, and all of them should be connected all time. This is called Internet of Things. How is Internet of Things different from wireless sensor networks? How is it different from cyber-physical system? Is a common question that anybody will ask right in the beginning. I will answer that. Wireless sensor networks is a very simple setup comparing Internet of Things, whereas the cyber-physical system is a complex setup. Wireless sensor network is nothing but collecting data from multiple sensors in parallel or simultaneously in a coordinated manner. I do not have any intelligence coming into picture there to process the data or to take action on the collected data, etc. It is going to be just collection of data but in a coordinated manner. When you come to cyber physical system, it is more than IoT. It is very complex. You can take an aeroplane as an example for cyber physical system where there would be multiple engineering domains coming into picture. Aeroplane has got mechanical engineering, civil and structural engineering, electrical engineering, electronics engineering, computer science engineering, and it is such a massive structure involving lot of environmental factors into it while flying and not even and while not flying also. When you take a lot of these kind of stuff into consideration for you to take a control action or for you to monitor the system, it becomes very complex, and that's what is referred as cyber physical system. Our human body can be referred as such a complex system. It is not easy monitoring it. So that is called cyber physical system, where IoT can play as one of the very important components out of the existing systems, but IoT is not everything there. IoT becomes one of the components. So to clarify it very clearly, wireless sensor networks is the beginning where they just collected the data in a coordinated manner. IoT is what we are in right now. We collect the data, we process it, take some control action, but at a minimal level. Cyber physical system is going to be the future. In fact, it has already begun. So it is going to be the future where you will collect data from a large structure, massive structure, and you will take real-time control action where IoT will be one of the important components. That's it. IoT is not one technology, it is collection of technologies and collection of multiple domain knowledges coming together. A mechanical engineer cannot anymore say that I am just a mechanical engineer, I will work on mechanical stuff. Computer engineer cannot say that I will just code. Now you will have to come together with multiple domains together to build a system, and the system is going to be interdepartmental and it is going to have multiple technologies working together. The data is going to be everything. The data is vital. The data is going to be the heart, kidney, liver, you call whatever you want. And acquiring data is going to be the very important process while processing it and then taking action will be the next important stuff which are to be queued up. Now, this session will give you a clarity about what, how, and why. That's it. Let's understand the history a little bit. History is very important wherever you go. And reports all suggest that it started by 1990, where internet has started booming. Only 300,000 desktop computers were there connected to the internet. Just 300,000. Think of it's very less, right? In 2000, it grew almost to 300 plus million desktop computers, which also included the laptop computers. In 2016, which is not too very late, it is in the recent past, 2.5 billion mobile phones are connected to the internet. Now, think of 2019, everybody has got one mobile phone at least, and some of us have got two phones, and all of them are connected to internet all time. So the count is going to be terrific in near future, where we are going to have 15 billion devices connected to internet by 2020. The devices include a refrigerator, kettle, water heater, camera, lights, home equipment. You call anything and that would be connected to internet in future. Future is not so far again. It's just 2020 is what is the prediction. About 4 million navigation systems will be connected to internet. Think about it, 4 billion navigation systems. Earlier, the GPS support system and the navigation systems were very expensive. In US, you'll have to subscribe and buy. In India, it was not even there. But now you have Google Maps, which is going to help you out like anything. So, 4 billion navigation systems. Connected cars would become a reality. 500 million wearables, watches, shoes, everything will be connected to internet. Hundreds of millions of implants in human and animals who talk to internet. So what do we expect? It's very simple. Everything is going to be connected to internet, and there are a lot of opportunities. You need to monitor all the equipment, and for that you need internet of things. So the know-how of internet of things becomes mandatory. That's the reason we are diving deeper into internet of things, and the next stage would be cyber-physical systems. Let's take a very simple example. From the time you wake up till the time you go to bed, how do you think IoT can change your life? Very simple. The morning, the time you wake up can be regularized, and the machine learning algorithms can be used to keep an alarm based on the pattern that you wake up every day. So I'll have an alarm that is connected to internet. It will have a machine learning algorithm running inside, and it will predict when do you wake up on every particular day based on the work that you are doing, and it can wake you up. By the time you are about to wake up, it can ready the water heater with water being heated up at an appropriate level. By the time you are bathing, the kettle can have the bread ready for you to eat in the breakfast. And by the time you have done with you are almost done with your breakfast, the doors will be open for you to leave the office. When you open the door, the cars can automatically get opened, and you are all set to go into the car. By the time you are driving, your map update should come real time, and that is all internet again. And by the time you are nearing office, obviously you need to know where your parking space is available. So the parking space update will come to your system, and you can go and park your car there. And this is it. And by the time you reach office, if you have any tablets to be taken, our pillbox can alert you. The pillbox can tell you that, boss, take your tablet, you have forgotten. And that alert comes again through IoT. Now, after the work is over, you may have to come back in the evening. And while you are coming back, you need to have a lighting setup in the house which reflects your mood. If you are in a very good mood, the lighting can be accordingly done. If you are in a bad mood, the lighting can be accordingly done. All these things are possible through IoT. And your refrigerator should order the milk or egg based on necessity. The bedroom AC should be automatically on before you get into the bedroom for sleeping. All these things are possible, and they are already reality. It is not that they are just projected. All these have been done, and this is called high-end automation with IoT. And all of these can be done by all of us. The point is, it is not so complex. It is all easy, all possible by all of us, but only thing is you need to know how to do it and how exactly to start it. That's what our book is going to help you. Our book is going to give you a feed as in how to start. The problem statements that we have taken are all real-time problem statements, and we have solved it and we have provided you the code. And in the book, if you see, we have got YouTube links also to certain very important topics where we have taught it, and we have also shown you how the interfacing and all are done. So it's going to be very helpful for any beginner who wants to learn how to start IoT from scratch, while the expert user can know where exactly the applications can be taken from. We have taken the application sectors as very simple applications, right from the very simple medical application till the most complex applications we have taken and we have built. So that would definitely be helpful for you. I request you guys to see the book table of contents so that you can understand it better. To conclude, for the first topic, IoT is all about anytime, any device, anyone, any service, any business, any network, anywhere, any location. It's very important to understand what is it. I can access the sensor anytime. I can connect sensors to any device with internet again. Anyone can use IoT. Any service can be provided. Any business can be enhanced or monitored using IoT. And any network, you cannot or you need not stay stuck to only one network. And it is all heterogeneous. I'm telling you, it is not homogeneous. It's a greatest advantage. I can use a laptop which is made by HP. I can use a sensor which is made by Texas Instruments. I can use another component which is made by Dell, and it's all going to be heterogeneous even with respect to components. So it is the biggest advantage. You need not stay or get stuck to one particular manufacturer anytime. And IoT is for any location, anywhere. You can go even deep inside the sea to monitor the pipelines which are running. You can go high in the sky to check the temperature levels, the rain, all those atmospherical changes. All these are possible with IoT. So to define it clearly, IoT enables the objects, which eventually are nothing but the things, to be sensed while also controlling it remotely, which enables better interaction of the physical world to the computers. This would improve efficiency, accuracy with limited human intervention. This is a very important point. It is with limited human intervention. That's what you should understand. Now, Cisco BSG in 2011, they have predicted that its growth is going to be 50 billion smart objects are there. You can see that it's going to be 50 billion smart objects. By when? It's very simple, by 2020. They are just calling about the smart objects, 50 billion. So the opportunities are going to be plenty if you start working in IoT area. That's the point that I would like to stress again. IoT is easy. IoT is having a lot of scope in the future. So pick it up. 6 things per person is what is going to happen in future, which is not so far again 2020, just 1 year away. So the predictions on 2011 says that in 2020, which is the next year, 6 things on online per person will be there. This is a rapid growth. Okay, now where all we can use IoT? Where exactly IoT is utilized? IoT is used in many areas, starting from the vehicle, asset, pet, and human tracking. I can track my vehicle with an RFID reader. I can use IoT there. I can track if my vehicle is all safe. Baggage during the airport transfer is a biggest problem, and many baggages are lost, and we can track it using IoT. Pet tracking, and at time human tracking also. Agriculture and resources. We have dealt an example of how water quality can be monitored towards agriculture enhancement using IoT. IoT has got a lot of scope for agriculture, so it's the biggest opportunity, in fact, for us to enhance the agriculture right now. And coming to energy sector, yeah, energy has got a lot of scope. We can use IoT very much effectively in the energy sector to save power and to generate power as well appropriately. The most important area where IoT is being used right now in the industry and even in residences, even in the um, normal living areas, in the normal areas where the elderly people are even available, which are to be monitored, the hospitals, is the safety, vigilance, and surveillance systems. Cameras with IoT is going to be the biggest combination, with a little bit of algorithms there running inside, can let you live safe, as well as it can help you in monitoring. It can alert when there is an untowardly event is happening. So all those are possible. The embedded applications, mobile applications, healthcare, telemetry is one of the areas where IoT is booming up like anything. And most importantly, smart city, smart water, smart dustbin management, smart traffic. So many things are happening, and almost all of this are dealt in our book with an apt example, with a real-time project in picture, with a demo as well. So please go through it, and if you have any queries, you are always welcome to ping me out through my channel or through my email ID, which I'm going to provide you at the later part of the session. What are the characteristics of IoT? First one, connectivity. You must have continuous connectivity. What do you mean by that, sir? Very simple. I'm going to monitor a water pipeline or an oil pipeline which has to be monitored continuously. The oil pipeline, if it has got a breakage or if it's damaged, it should be alerted immediately. And when the damage is found through the available sensors there, if internal connectivity is going on and off, I may not be able to update. And if I miss even 5 minutes of time, that it would be very fatal. It may cause damages, it may kill people. So connectivity is extremely important for any IoT based project. Intelligence and identity. The next one, I have a lot of sensors available. The sensors are feeding in data at a very high and a rapid rate. So I need to understand who is sending the data and what is the data. So intelligence is very important and identity is very important, as in we need to understand who has sent the data. Next is scalability. IoT should work for 10 people, IoT should work for 20 people, IoT should work for 100 and 1000, and it should scale down also. So you cannot say that I'll have only 10, I can have only 100. Now you should be capable of building an IoT application which can scale up or scale down. Most important point, it should be dynamic and self-adapting. Configuration should be done just for the first time when you are installing the setup. If it keeps asking you for human intervention to set up things every time, it is going to be really troublesome and it would not go well in the market. Architecture. IoT is all about heterogeneous architecture, which means that you can buy any manufacturer's equipment, but only thing is you need to connect them as appropriate as it has to be connected. The final and the foremost important thing is safety. You have to be safe because you yourself are wearing the equipment. It should not give you any damages with respect to the radiations, the power, etc. At the same time, the data that you are acquiring is all to be safe. If there is a damage in the data, if there is an alteration in the data, it might not give you the correct status that we are trying to understand and acquire. That's a huge problem. So you got to be safe and your data has to be definitely safe. It's the market. So IoT is all about connectivity, intelligence and identity, scalability, dynamic and self-adapting setup. Architecture should be heterogeneous, followed by ensuring the safety. Now, IoT, what is the things? I'll make it very crisp. We are running out of time. I'll make it very crisp. What can be the thing? Your fan, mobile phone, shoe, water heater, cooker, bulb, refrigerator, washing machine, kettle, aeroplane, computer, anything can be a thing. Only thing is they need an address. They need an identity. If you have an identity, you can become a thing in the IoT. The major thing that you need to remember is without identity, a thing cannot be rated as a thing in IoT. So the address can be a MAC address, IP address, or whatever, but it must have an address. Without address, you lose identity, and without address, you cannot become part of the IoT loop. That's very, very important. So please remember that. So what are all the famous things that you are already aware of? Temperature sensor, pressure sensor, humidity sensor. All these are the sensors that I'm talking about. Hence, they will become the obvious things in any IoT network. When you see about sensors, you can ask me a question. Is there anything else that I can connect to it easily? I mean, any other things can you cite easily? The industrial motors, the wearables, the vehicles, shoes, they all become things again. Only thing is, they need to have identity. Without identity, a thing cannot be classified as a thing for Internet of Things. Remember it. I'll give you some examples again. Heart monitoring implants. Pacemaker is the best example that I can give you. That is a thing. Biochip transponders. It is used in the animals in the farms. They have things and they are rated as things. Automobiles with built-in sensors. Obvious. Food perishables quality monitoring. Nowadays the perishables are being transported or monitored for quality during the transport itself, and then intelligent decisions are taken. I have done a project on this and I have included that in this book. So you can refer to it and you will understand that how exactly IoT can be used for such a kind of wonderful applications, which is actually inexpensive yet very effective. So things can be hardware, software, data, and service, whatever you provide. Altogether contribute to creating the things. So IoT is Internet of Things, where things can be anything that you work on, but they need identity. This is the only thing that you need to remember. So in a home automation, what are all the things that you know? Control and automation of lighting, heating, ventilation, air conditioning, appliances such as the washer and dryers, air purifiers, ovens or refrigerators. All these come under the category of things. So please understand, they all must have address. The last topic that we are going to talk about now is IoT Stack. What does the IoT Stack have? Or how do you build an IoT application? The first layer that you need to understand is called sensor layer. The sensor layer is equivalent to the physical layer that you have studied in the OSI layers. Here we will determine which sensor we are going to use. Is it a temperature sensor, pressure sensor, humidity sensor, etc. Picking up sensor happens here. The next layer is very important and it is called as the microcontroller layer. The sensor data should all be processed in the microcontroller without fail. So I need to select my appropriate microcontroller and the data has to go on to the microcontroller for it to be processed. Microcontrollers can be PIC, ARM, Intel boards. Here I have to say about something from Intel. When you take the boards like Node MCU or Arduino, they might not have the industry standard to implement them in the industry. You can build the prototype, you can test if the prototypes are working fine, your idea is working fine, but you cannot really deploy it in the field. But when you go to the Intel boards, for example, the UP Squared, AI Vision board, all these boards are really available in the market. They are a bit expensive, I agree, but they are the best for you to even test it out with the industry range data, industry range environment. All these things are possible with the Intel UP Squared boards. I am an Intel innovator, so I am telling you this loud. If you want to really implement the project for real time, initial phase of building it up with Node MCU is absolutely fine. But for you to implement it later in the space where you need to really run it, you have to select a better board that can be Intel. So Intel's UP Squared board or Intel's UP Squared AI Vision board would be much more helpful for you. Now the first layer is the sensor layer. The second layer is the microcontroller layer where the data goes. The third layer is the hardware interface layer. I have a lot of peripherals connected to my system. I have a lot of sensors. So how do I interface the sensors to the rest of the components, to the microcontroller? I need cable. The cable can be RS-232, USB, I2C, SPI, CAN, etc. So the first layer is sensor, second layer is microcontroller, the third layer is hardware interface layer. Now coming to the fourth layer, I need internet connectivity, right? I need Wi-Fi, BLE or NFC. BLE is Bluetooth Low Energy. I need NFC. NFC is near field communication. All these come under one category called as RF interface layer. I need to collect the data, put it back onto the cloud. So for that I need internet. So for that internet, I will rely on any of these. The fifth layer is nothing but the session layer, which is also called as the message layer. I need to acquire all this data and send it across all carefully to the cloud without dropping the data. That is very, very important. If there is a mismatch or if the data is altered, it will create a lot of problems. So we have protocols working on it to ensure that the data is sent in an appropriate order. So we have MQTT, HTTP, COAP, all those protocols available for that, and we have dealt it in depth in our book. No other book to our knowledge has dealt it that detail. We have given the code, we have given complete explanation with implementation. I mean the hardware implementation also is given. So I request you to go through it. And the sixth layer is going to be the user experience layer. Finally, it is going to be an end user who is going to have an Android app in hand to test or an Apple iOS app in hand to test what exactly has happened. That is the sixth layer, followed by which is the application layer. What application are you building? Smart home, smart city, smart parking, smart energy, smart retail, smart agriculture. All these can be built, and all these together will constitute you the complete IoT protocol stack. I have given an example here for you to understand how exactly the stack is reflected in a practical and a real-time product that we have built for vegetable quality monitoring. You can see that here we have got a lot of fruits here. I have got sensors here. These sensors are nothing but the sensors which measure the humidity, temperature and odor for the vegetables that are available here. All these are taken real time and the data goes to the microcontroller that I have had here, and the microcontroller is nothing but the node MCU. They are powered by a power bank that you can see here. This data is collected and sent to the microcontroller, and with internet support it goes to the cloud, and there the processing all happens. And each box, there are multiple boxes like this. Each box is graded as ABC that reflects the quality of the box. Now you can see that the data comes to the cloud real time. So here what do? We acquire the sensors. We acquire the data from the sensors, layer 1. We use microcontroller, layer 2. We use cables for interfacing, layer 3. We use internet, Wi-Fi. We use MQTT protocol here for sending the data in appropriate order. Here you see the Android app. This is the user interface, and the application is finally called as Smart Perishable Management. That's it. It's a very simple setup that we have built. This has been explained pretty clearly with the code and other demos as well in the book, and also the channel that I have referred to you in the earlier discussion. So I request you to go through it to get a very clear understanding there. Now, what are all the fundamental things that I need to understand and learn for me to become an expert in IoT? First, know about sensors. Second, know about data analytics. Third, how do you control? After analyzing the data, you must have come to a decision. How do you take the control action? Fourth, how do you ensure that the security and privacy is all safeguarded? If you know four of these or two of these, you can say at least two of these, you can say that you can work in IoT. Knowing all the four is difficult right in the beginning. You need time and expertise with training for it. We have covered all these extensively in our book. It started with the sensor, it went to data analytics. We have got a 50-page chapter which talks about data analytics and machine learning in a detailed way. And then control action, yeah, we have done a lot of experiments that can tell you how exactly control action can happen. And security, we have taken case studies and explained you how exactly security matters. So all these are covered, and these all together constitute IoT. IoT challenges, quickly I'll complete it. First one is security, the personal safety and the data security. Privacy, yeah, we are collecting data, acquiring data, all these are real time. Do we have privacy? You will have to ensure it. The data extraction from the complex environment. Okay, sir, I'm acquiring data. If it is deep under the sea or high above the sky, how will we acquire? That's challenging. So you need to really take care of it. Connectivity. I told you this long back. Connectivity is all the very important thing in IoT, and without connectivity, nothing works. Power requirements. Most of the IoT equipment are battery operated. If they keep drained and keep draining, it's going to be a difficult stuff for us to handle. So the power requirements are to be handled properly. IoT is easy, but not very easy for you to right away jump in onto it. It requires a lot of different domains to come together. Different expertise are required. Toolkits, software, hardware, etc. are all not really abundant, though they are available. So you need to pick up the right one, and you need awareness. And finally, do we need cloud? Which cloud to use? How to identify? How much does it cost? Do we really need cloud? All these questions will come into your picture the moment you start with IoT. So all these are the fundamental challenges that one would really face when they are building applications. I would request you to go through our book chapters. Sample chapters are available in the website. You've got the detailed TOC available in the website. You can reach us out for any queries. I'll be more than happy to answer you. I hope the session was useful. Please go through the channel to understand things better. Everything is clearly documented in the book, which will definitely let you understand IoT in the way it has to be understood. That's our major target that we have handled. Thank you very much for listening to the session. I hope it was interesting and useful. You can reach us out for feedback, queries, suggestion, input. Thank you very much.